Welcome to the Deep Dive. I want you to take a moment and consider something extraordinary that touches, well, pretty much every part of our lives. Yet, we rarely think about it. What actually goes into ensuring the quality of the air we breathe, or the safety of the food we eat, or just the sheer incredible efficiency of massive industrial operations. It's definitely not magic. It's this incredibly specialized world of analytical measurement and custom engineering that makes it all possible. Today, we're taking a deep dive into that world, drawing on some fascinating insights from a company called AAVOS.
That's right. And our mission for this deep dive is really to uncover the critical, often unseen role that precise answers and proven technologies play. They're absolutely fundamental. I mean, everything from meeting strict environmental regulations to optimizing the largest industrial processes relies on this stuff. And what's truly insightful here, I think, is that these aren't always just, off-the-shelf gadgets. They're frequently custom-built, tailor-made solutions designed to guarantee constant accuracy and optimal equipment performance, no matter how unique or demanding the challenge might be.
Okay, so let's unpack this core promise from AVOS a bit. They make it pretty clear, if you can't find an out-of-the-box solution, that's where they really shine. They specialize in finding and building completely custom solutions for analyzer and sampling projects. So it's not simply about shipping a piece of equipment, is it? It sounds much more involved. They talk about providing turnkey custom system engineering. Does that mean they handle everything, like from start to finish?
Yeah, exactly. When they say turnkey system integration services, they genuinely mean comprehensive. It's like building a custom home, maybe. One company handles it all, from the blueprints right up to handing you the keys. For AAVOS, that starts with feed support, basically helping clients figure out their exact needs, the scope of the project right at the beginning. Then it moves into detailed design services, engineering, and the actual construction and integration of the system itself. But the turnkey part goes further. They manage quality assurance, quality control. They conduct factory acceptance tests before it ships, and then site acceptance tests once it's installed on location. They also handle the startup, provide on-site training for the client's team, offer ongoing maintenance contracts, troubleshooting if anything goes wrong, and even expert consulting.
Wow, okay. That is truly comprehensive. So what do these integrated solutions actually look like in practice?
Well, they can appear in many forms. You might see robust shelters, sort of like small buildings housing the equipment, or specialized cabinets, or precise sample panels, environmental enclosures designed for specific conditions, even full process analyzer systems built specifically for hazardous locations. And the applications are incredibly diverse. We're talking crucial environmental reporting, petrochemical operations, power generation, and LNG facilities, liquefied natural gas.
That brings us to a really crucial area where this precision makes such a huge difference. Environmental monitoring and compliance. This isn't just about ticking regulatory boxes, is it? This is where these measurements have a direct, undeniable impact on our safety and the planet's health.
Absolutely. I mean, just imagine trying to precisely measure invisible gases, maybe flowing at hundreds of degrees 2047. You have to do that to ensure a plant avoids massive fines, but also, more importantly, keeps our air breathable. That's the challenge. Continuous emission monitoring systems, or CEMS, tackle. These systems are put in place to optimize how a plant operates and ensure they're complying with often very strict environmental regulations. A typical CM acts like the industrial world's unblinking environmental eye, you could say. It's constantly measuring pollutants in stack flue gas streams, things like nitrogen oxides, NOx, sulfur dioxide, SO2, carbon monoxide, CO, carbon dioxide, CO2, oxygen, O2, and ammonia, NH3. And they are comprehensive systems. They're also designed to measure flow, dust levels, other air pollutants too. Plus, for situations needing mobility, maybe for spot checks or research, there are portable options like the PD300 series. These can measure up to 5 gases simultaneously, including critical greenhouse gases.
Okay, so it's not just the big fixed systems then. Industrial emissions and sampling must involve a lot of other specialized tools beyond those main CEMS units.
Precisely. Yeah, for sampling and measuring industrial emissions, or even just general air quality, you need specialized sampling probes. These have to be highly adaptable to all sorts of industrial emissions and gas compositions. And that often means you need truly customized solutions, not just a standard probe. And here's a critical detail you might not think about. Cooling and condensing devices. They're vital in stat gas sampling. Why? Because they quickly lower the gas temperature. This stops condensation forming, which could damage sensitive instruments downstream, and it also ensures the chemical stability of the sample itself so you get an accurate analysis. It's about getting that perfect sample every single time. Plus, for maximum flexibility, there are automatic portable samplers. Some are even isokinetic.
Isokinetic. What does that mean exactly?
It means the sampler draws in the gas at exactly the same speed as the gas flowing in the stack or duct. So you're getting a truly representative sample, not skewing the results by sampling too fast or too slow, like getting a perfect slice of the airstream. And these portable samplers are used for stack gas, obviously, but also for outdoor air quality checks and even indoor air quality assessments.
Wow, that's incredible precision just for collecting the sample itself. Okay, what about broader sort of general air quality monitoring beyond specific industrial stacks?
For that, you'd look at air quality monitoring stations, or AQMS. These are, again, comprehensive systems. They're designed to continuously gauge both meteorological factors, things like wind speed, wind direction, rainfall, temperature, atmospheric pressure, and ambient air conditions. AQMS incorporates specific ambient analyzers for continuous monitoring of various air pollutant concentrations, things like SO2, O@X, CO, ozone, total hydrocarbons, and importantly, particulate matter, and they even offer mobile monitoring stations. These can be moved around to where the data is most needed, maybe for specific studies or emergencies.
Right. And with all the talk about particulate matter pollution, I guess dust and particulate monitors must be absolutely essential for public health assessments.
They truly are, yeah. Ambient particulate monitors sample, measure, and record concentrations of TSP, total suspended particulates, PM10, PM2.5, or even combinations like PM10, 2.5. To give you a sense of their global impact, the beta attenuation mass monitors, or BAMs, are used all over the world for applications demanding really high accuracy. I think the source mentioned over 15,000 have been sold, and they've got certifications in the US, Europe, China, Korea, Taiwan. Very widely accepted. There are also advanced analyzers like the PX375. This uses automated sampling for continuous online analysis, not just how much PM there is, but also what elements are in that particulate matter, quantitative and qualitative.
I've heard a lot about black carbon recently, particularly in discussions about climate change. Is that measured in a similar way?
It is related, yes, but it's a more specialized area of measurement. There's a brand, Aerosol McGee Scientific, that's really at the forefront here. They have scientifically proven methods for measuring these carbonaceous aerosols. And get this, their instruments have provided data for nearly 8,000 published scientific papers.
1,000, wow.
Yeah, it's a huge testament to their accuracy and reliability in the research community. Their carbonaceous aerosol speciation system, or COS, for example, combines different analyzers. It measures total carbon, elemental carbon, organic carbon, and black carbon, all in suspended aerosol particles, and it does it in near real time. Getting that level of detail is vital for understanding where air pollution is coming from and what its impacts are, especially on climate.
It's just incredible to think how all these detailed, seemingly invisible measurements contribute so directly to cleaner environments. And helping companies meet these incredibly stringent regulations, it directly benefits you, the listener, and all of us, really. Now, here's where I think it gets really interesting. These precision measurements aren't just confined to air quality, are they? They seem to extend into some surprising other areas, helping safeguard communities and optimize operations in ways you might not expect.
Absolutely. Take noise and vibration monitoring, for example. These systems are vital for safeguarding individuals, communities, the environment, really, from undue noise and vibration. It's a common concern around industrial sites, construction zones, things like that. You'll find integrated multi-parameter monitoring stations that measure, record, process, store, and transmit real-time data on noise and vibration levels. And what's particularly fascinating, I think, are tools like acoustic cameras.
Acoustic cameras, what do they do?
Imagine a camera, but instead of just seeing light, it can actually see sound. It pinpoints exactly where a sound is coming from. So you could identify a specific faulty machine in a noisy factory, or maybe pinpoint which piece of equipment on a construction site is exceeding noise limits. These are often used alongside standard sound level meters for environmental noise assessments and even checking building acoustics.
So it's not just what's in the air, but also the physical impact of industries on their surroundings. That makes perfect sense.
Indeed. And speaking of physical conditions, meteorological monitoring is another crucial area. You mentioned Met1 instruments earlier. They initially specialized in meteorological instruments. Their sensors are built to be durable, to withstand harsh outdoor environments. They measure all the key factors: wind speed and direction, temperature, relative humidity, rainfall, solar radiation, atmospheric pressure, even visibility. This data gets packaged into systems like general-purpose weather stations, industrial ones, rapid response units, and specific air quality weather stations, all providing critical data for everything from optimizing industrial processes, maybe adjusting operations based on wind direction, to informing emergency response plans.
I can definitely see how critical that data would be for safety, for planning,
Yeah.
and even for predicting environmental events or dispersion patterns.
Exactly. And if we move underground, tunnel sensors play a vital role. With the growth of smart cities, more extensive road networks, monitoring in road tunnels is critical. It's about safety, obviously, meeting regulations, but also maintaining the longevity of the tunnel infrastructure itself. These specialized analyzers measure everything from tunnel visibility, is it getting foggy or smoky, to airflow, gas levels like CO from traffic, luminance, and illuminance, making sure it's safe to drive through.
It really feels like all of this is about creating a safer, more predictable environment, doesn't it?
Mhm.
Okay, what about the air we breathe indoors, especially in highly specialized places like clean rooms?
Ah, yes. Indoor air quality and clean room monitoring, that's another critical application. In environments like pharmaceutical manufacturing or microchip production, maintaining ultra-clean air isn't just important, it's absolutely non-negotiable. Any contamination can ruin products worth millions. So you have handheld and benchtop units specifically designed for cleanroom applications. They adhere to extremely strict standards like ISO 13644, 1.2015, class 3 to 9. These devices often integrate seamlessly into existing facility software and building automation systems. That ensures data integrity and constant compliance monitoring. Think about portable dust monitors and handheld particle counters. They're essential tools in these sensitive environments, making sure even a single rogue particle doesn't compromise a critical process.
Right, and of course the huge global topic, greenhouse gases. The sheer scale of measurement needed there must be enormous.
It is. Measuring greenhouse gases, or GHGs, like carbon dioxide, CO2, methane, CH4, nitrous oxide, N2O, and those fluorinated gases, well, it's profoundly significant. These are the gases recognized as major contributors to global warming. And the capability exists now for simultaneous measurement of multiple GHGs using single analyzers. These measurements are applied in a really diverse range of settings, from sewage treatment facilities, waste treatment plants, chemical plants, all the way to extensive research and development initiatives focusing on climate change mitigation.
Okay, let's shift our focus now. We've talked a lot about the environment, both outdoors and indoors. Let's move to the very heart of industrial efficiency and product quality. Online process analysis. This is where, raw materials get transformed into the finished products we rely on every day. Precision here isn't just important, it must be absolutely paramount. How do they achieve that level of exactness?
Well, we're moving into the realm of some really sophisticated tools now. Many of them essentially probe the molecular structure of materials using light. It's a powerful set of techniques broadly known as spectroscopy.
Spectroscopy. Sounds incredibly precise, but for someone maybe new to this, how does it actually work? And you mentioned surprising applications before. What's a really interesting way it's being used today?
Great question. Let's take Raman spectroscopy as a fantastic example. It's known for being incredibly selective. It can pick out specific molecules even in complex mixtures, and it's non-destructive, so it doesn't damage the sample. What's truly unique about Raman is its advantage in aqueous solutions, basically anything dissolved in water. Other light-based methods, like FTIR, can sometimes struggle because water itself absorbs a lot of infrared light. Raman doesn't have that problem. Some specific systems, like Tornado Raman spectrometers, use proprietary technology, they call it HTVS, to deliver measurements that are an astonishing 10 to 30 times faster than conventional Raman. Plus, they get better sensitivity. That means lower detection limits, even in potentially hazardous ATEX-rated environments. It allows for reduced laser power too, which is safer, without sacrificing performance. And here's that surprising application. Handheld Raman units. They're widely used by law enforcement agencies, think hazmat teams, border control, and also in the pharmaceutical industry. They're almost like those sci-fi tricorders. They can instantly identify unknown substances, narcotics, explosives, hazardous chemicals, or verify the authenticity of pharmaceutical ingredients right there on the spot.
Wow. So essentially, a portable lab that can identify potentially dangerous substances in seconds. That's incredible. What about other light-based techniques? You mentioned NIR and FTNIR.
Right. NIR, which stands for near-infrared, and FTNIR, that's Fourier transform near-mid-infrared, are also incredibly versatile and reliable instruments. They're workhorses for real-time, non-destructive analysis of process streams. What that means is you can monitor product quality or chemical reactions as they happen, right in the pipe or reactor, without having to constantly pull samples and take them to a lab. Some models, like the guided wave Inorio process analyzer, offer multi-channel analysis. That means they can look at multiple points in a process simultaneously using fiber optics. They boast excellent signal-to-noise ratio, which means you get really clear, reliable data. And critically, they have NIST traceable wavelength calibration. That means their accuracy can be directly linked back to national measurement standards. It ensures unparalleled reliability, which is vital when you're controlling a process.
I understand FT&IR is particularly important in places like refineries and the petrochemical sector. What specific challenges does it help overcome there? It must be a tough environment.
Absolutely. That's a perfect example of where this precision meets real-world practicality. In a refinery, you're dealing with incredibly complex mixtures, crude oil, gasoline, various intermediate streams. Ensuring the quality of fuels and chemicals is just non-negotiable. The Analytic series of FT&IR process and lab analyzers are designed for this. They measure physical and chemical properties across a broad spectral region. They use something called a process-proven analytic transept interferometer, which provides superior performance for complex applications like optimizing fuels blending or monitoring component streams for making polymers or chemicals. They offer specific solutions too, like Refinger, which is an integrated lab autosampler for quickly analyzing crude oil or gasoline samples, and the Hydrocarbon Smart System, which is designed for real-time online monitoring right in potentially hazardous areas of the plant. But let me tell you about the Armadillo by Keat. This thing sounds really neat. It's a compact, really tough inline FTR spectrometer. It gets real-time analysis right at the point of production. What makes it potentially revolutionary is that it has no moving parts. And it uses a diamond ATR tip that's the bit that contacts the sample. This makes it incredibly resistant to vibration, extreme TH levels, and high temperatures. In a turbulent industrial environment, having no moving parts means it can deliver laboratory-grade precision without errors caused by, things shaking around or wearing out. It enables really unwavering quality control.
No moving parts in an analytical instrument in a refinery? That sounds almost indestructible, really robust.
Yeah.
Okay, so if spectroscopy is about identifying what's in a sample using light, how do mass spectrometers fit into this picture?
Mass spectrometers. Think of them as the ultimate molecular detectives. They tell you exactly what's in a sample, often down to its elemental or molecular composition, and how much of it there is. They provide incredibly high sensitivity and a really wide dynamic measurement range. They can measure things from parts per billion, tiny traces, all the way up to percentage levels. This gives you a full speciated composition, meaning it identifies each individual component in gas and ion analysis. This is absolutely critical across industrial process control, environmental monitoring, and definitely in cutting-edge research. You have different types, like quadrupole mass spectrometers. They're incredibly versatile. You can use them for identifying unknown compounds, measuring isotopic ratios, different flavors of the same element, or even monitoring how fast chemical reactions are happening in real time. It's about getting that complete molecular fingerprint.
So they identify precisely what's in a sample, down to minute details. What if you need to detect just the tiniest trace of something unwanted, like an impurity in a gas, or identify very specific compounds in a mixture?
Right, for those ultra-sensitive, highly specific measurements, that's where laser gas analyzers really shine. Technologies like TDLAS, that's tunable diode laser absorption spectroscopy, QCL, quantum cascade lasers, PAS, photoacoustic spectroscopy, and CRDS, cavity ring-down spectroscopy. These are all powerful tools specifically for trace gas analysis. For example, TDLAS analyzers use lasers with a very, very narrow bandwidth. Think of it like an incredibly precise spotlight that only illuminates one specific molecule. This allows for high-resolution, highly selective detection of specific compounds, even when they're present at very low concentrations, like parts per million. Crucial for things like ensuring product purity in semiconductor manufacturing or chemical processes. Or QCL technology, Horiba's PLGA 1000 uses this, for instance, can measure low concentrations of impurities like acetylene and CO2, even when they're mixed in high concentrations of methane and ethane. That's a tough measurement challenge. Then there's PAS, photoacoustic spectroscopy. The ETG 8900 QEPS series is an example. PAS offers high time resolution, great accuracy and precision, and it can overcome some limitations of conventional instruments regarding robustness, portability, and even cost sometimes. And finally, if you need to detect things like moisture or other rogue impurities in really high purity gas streams, down to PPT, parts per trillion levels.
Parts per trillion. That's like finding a needle in a universe of haystacks.
Exactly. It's incredibly sensitive. For that, CRDS, cavity ring-down spectroscopy, is often the technology of choice. It provides unparalleled accuracy for the most demanding high-purity gas analysis applications.
That's truly microscopic levels of detection.
Oh.
Amazing. And one more spectroscopy type, UV-VIS. Where does that fit into the industrial puzzle?
UV-VIS spectroscopy, which uses ultraviolet and visible light, is another widely used technique. It's found in process and lab analyzers across a vast array of industries. Think chemical production, petrochemicals, refining, pharmaceuticals, food and beverage manufacturing, environmental monitoring. It's very versatile. It's often used for measuring color, concentration of certain compounds, or detecting specific substances in liquids and gases. Specific examples: the Guided Wave 508 UV VII Full Spectrum Process Analyzer is a workhorse in many industrial settings. For environmental applications, you might see the CEM 500 online gas analyzer, which boasts higher resolution and longer lamp life, making it great for continuous emission monitoring. And the UV 500 online water analyzer is critical for monitoring wastewater discharges or river water quality, helping to ensure our water sources remain clean. And beyond these core spectroscopy and mass spec techniques, there are other really specialized measurements that have a huge global impact. They affect everything from mining operations to pharmaceutical quality control. Take density and concentration measurement, for example. Simple refractometers are used everywhere, determining purity and concentration in medications, checking the sugar content, bricks, in food and beverages, analyzing petroleum oils. But then you have more innovative solutions, like the Rosonic Slurry Density Meter. What's interesting here is that it's non-nuclear. It uses ultrasonic technology for real-time density measurement. This is particularly useful in really harsh environments like dredging operations or mineral processing plants. Avoiding nuclear sources can be a significant advantage for safety regulations and operational simplicity. They also offer the Rosonics Chemical Density Meter, which gives real-time info on total suspended solids, TSS, total dissolved solids, TDS, and density in various liquids and slurries. And that's complemented by their Chemical Concentration Meter for specific chemical measurements.
That's fascinating. A non-nuclear option for measuring density in tough slurries. Why is avoiding nuclear detection sometimes important in that kind of context? What makes it smart engineering?
Well, using non-nuclear methods often simplifies regulatory compliance significantly. There's less paperwork, fewer safety protocols associated with handling radioactive materials. It can reduce safety risks for personnel and potentially lower operational costs related to licensing and disposal. And it still delivers the precise density measurements needed for critical process control in those really tough, abrasive environments like mining. It's smart because it finds a different, often simpler way to get the same essential data. Moving on, another specialized area is paper tape for sulfur compounds. Measuring sulfur compounds like H2S, hydrogen sulfide, and processed gas or liquid streams is absolutely critical.
Why sulfur specifically?
Well, for two main reasons: safety. Many sulfur compounds, especially H2S, are highly toxic, even at low concentrations. And quality sulfur can be corrosive, it can poison catalysts used in industrial processes, and it affects the quality and specifications of products like natural gas or fuels. So these paper tape analyzers are designed specifically for this. They offer a very wide measurement range, detecting sulfur from low parts per billion up to percentage levels. A key advantage is they typically have no interference from other compounds in the stream, which can be a problem for other sensor types. And they're suitable for use in hazardous areas. Specific models mentioned include things like the Devel Sulfa Analyzer, which measures both H2S and total sulfur, the Nova Sulfa series for either H2S or total sulfur, and even the water sulfur for measuring dissolved sulfides in water streams.
Okay, that makes sense. Safety and quality control. And finally, you touched on physical properties for refineries earlier. I imagine even something seemingly simple like color could be incredibly important for a final product like gasoline or diesel.
You're absolutely right. Even color is a critical quality specification for many refined products. Automated process stream analyzers are used to continuously measure these key physical properties. So yes, color using instruments like the Hallekinen Model 7613. Also, vapor pressure, which is crucial for fuel volatility and performance. The ATAC Model 1354 measures Reid vapor pressure, a standard industry test, and viscosity, how thick or thin a fluid is. ATAC provides viscometers that can handle both simple Newtonian fluids and more complex non-Newtonian ones, like heavy oils or a bitumen. All of these online measurements are non-negotiable for ensuring consistent product quality batch after batch, meeting strict fuel standards, and maintaining precise process control within the refinery.
So after covering all this ground, from custom builds to environmental monitoring to these incredibly precise process analyzers, what does this all mean? What's the bigger picture for us, the listeners, and the world we live in?
I think it means that companies like AAVOS, drawing on, as they mentioned, more than 30 years of direct analyzer experience, with roots going back to 1995, well, they're dedicated to empowering industries, yes, but also government bodies, researchers, scientists, and communities, empowering them with these integrated measurement technologies. And while their primary focus might be geographically in the Benelux region, their impact is truly global. Their analyzers are operating in some incredibly diverse and challenging locations around the world. The source material mentions places like the Amazonian forest, Antarctica, the African jungle, even on specialized equipment like airplanes, marine vessels, and military installations. Just think about the engineering challenge. Making an analyzer work reliably in the extreme cold of Antarctica or the humid heat and remote conditions of the Amazon, it really underscores their commitment to providing robust, accurate solutions literally anywhere they're needed. And beyond just supplying the hardware, remember they offer those comprehensive operations and maintenance services, calibration, technical support, training. Plus, holding certifications like ISO 9001 for quality management and VCA for safety, it all ensures these vital systems remain reliable and functional for years doing their critical jobs.
Wow. What a deep dive, indeed, into this vast, and let's face it, often completely unseen world of precise analytical measurement. From these huge, custom-built systems designed for unique industrial challenges, down to highly specialized instruments detecting the tiniest particles and gases. It's clear these technologies impact pretty much everything. The air we breathe, the water we drink, the complex products of modern industry we use every day.
It truly highlights the silent but absolutely vital role these advanced technologies play. You don't see them, but they're there. They are essential for ensuring environmental compliance, for optimizing how industries run efficiently, for enhancing the quality of countless products, and ultimately for safeguarding public health worldwide. They really are the unseen guardians, you might say, of our modern industrial society.
So, as you go about your day-to-day, maybe just take a moment to consider this. How many invisible, highly precise measurements are happening all around you, right now, constantly humming away in the background? Think about what's keeping our air cleaner than it might otherwise be, our water safe, our industries running efficiently, and producing high-quality goods we depend on. It's this hidden layer of incredible scientific and engineering dedication developed over decades that underpins so much of modern life. It's quietly ensuring our world is safer, more efficient, and better informed than ever before.